Welcome to EDU World Space.
Hi, everybody. Then determine the mass moment of inertia with respect of 0 and A. So we have, let's see if I can draw this kind of how we should. There we go. And so from here we have A, Z, this is X and Y. So we have A here. And then we also have A here. And this is capital A. And then we also have A here. We have 0 here. Okay. So now what we can do is have this as 1 and 2 space. There we go. So what we can do is find M1, which is going to be 1/2 WG. And your M2 is also going to be 1/2 WG. And now we can find OA, which is going to be 1 squared plus 1 squared plus 1 squared, which equals 3. And your OA vector is just going to be I hat plus J hat plus K hat. So your unit vector of OA is just going to be I plus J plus K over 3, root of 3. Okay, so we're going to scroll down. And so we need to find the moment of inertia at x1, which is going to be 112 m1 squared plus m1 a2 squared, which equals 112 w2g. Okay. And a squared plus w2g times a squared 4, and we get w2g a squared 12 plus a squared 4, and we end up with w6g a squared. And now for ix2, we have 112 m a squared plus a squared plus m of a divided by 2 squared plus a divided by 2 squared equals 112 of w2g times 2a squared plus w2g times 2a squared over 4. And now we have w2g a squared 6 plus a squared 2. And we get w2g here 4a squared over 6. And we have 2/3 wg. So we end up with 1/3. 1/3 g a squared. And you can just actually just do 3 a squared. There we go. And so your ix total is equal to ix1 plus ix2. So we get w6g a squared plus w3g a squared. And now what we're going to do, and we're just going to do the math to multiply, so we get 1/2 wg a squared. And we're going to do the same thing to your iy1, which is going to be 112 m 2a squared plus m of a squared over 2. And from this, you can obviously tell that it's just going to be 1/3 wg a squared. And your IY2 is going to be slightly different. So we have 12MA squared plus MA squared plus A squared 2. Actually, we're just going to have this be A squared of 4. And so from that, we get 112 W2G A squared plus W2G of 5A squared over 4. And that is a weird 5, I know. There we go, 5. Still a weird 5, we're just going to accept it. And we have A squared 2G, and we have 112 plus 5 fourths. And 1A squared over 2G. We have 16 over 12. And this gives us 2WA squared over 3G. And then we can do the IY total, which is just going to be WA squared over 3, 1/3 plus 2/3, and we get WG A squared. And now for your IZ, it's just going to be 112 WA squared 2G plus W2G A over 2, so A squared over 4 plus 112 WA squared 2G plus W2G times A squared plus A squared over 4. And we get 5, 6 WA squared over G. And now we have IXY 1 equals IYZ equals IZX1, which equals 0. IXY2 equals IYZ2 equals IZX2 equals 0. Y1 equals 0. And so we have IXY equals MX2Y2, which equals W2G A2, which equals 4G A squared. And IYZ equals MY2 Z2, which equals W8G A squared. And we have IZX, which equals M2 Z1 X1 plus M2 Z2 X2, which equals WG 2G A over 2, A over 2 plus A over 2 times A, and we get W8G 3A squared. And now we have your IOA, which is going to equal 2IXYX squared plus IY lambda y squared minus 2IXY lambda x lambda y minus 2IYZ lambda y lambda z minus 2I vx lambda v times lambda x, and your lambda x equals lambda y, which equals to lambda z, which is 1 over 3. Okay, so now we can plug into IOA. We have 1/2 WG A squared, 1/3. And now we have WG A squared times 1/3 plus 5, 6 over WG A squared 1/3 minus 2w4ga squared 1/3 minus 2w8ga squared times 1/3 minus 2 times w8g 3a squared times 1/3. And now what we have is IOA equals to 1/6 plus 1/3 plus 5/18 minus 1/6 minus 1/12 minus 1/4. So I'm just gonna put in parentheses WGA squared equals 11/18 minus 1/3 WGA squared, which equals to 5/18 WGA squared. Okay, and that's the answer, guys.